Hello, welcome to Maths with EJD. In this video, I'm continuing with trigonometry as I deal with the idea of sum and product formulas. Okay, now these formulas show us how the sum of the sines of angles and cos of angles actually translate to some kind of products which will be necessary for us to do certain tasks like integration and all that. Because sometimes when you have some kinds of expressions, you may not be able to work with them directly. So you have to change maybe sum to product or product to sums before you're able to work with them. So let's go on the journey. So we're going to build on the idea of sum and difference formula for us to arrive at sum and product formulas. So let's go. Remember that sine A plus B is the same thing as sine A cos B plus cos A sine B. I like to call that equation one. In the same way, sine A minus B is the same as sine A cos B, sine A cos B minus cos A sine B. That's equation two. Then you also remember that cos A plus B is equal to cos A cos B minus sine A sine B. Call that equation three. And then you know again that cos A minus B is the same as cos A cos B plus sine A sine B. Like that. Call that equation four. So, I mean, we are used to talking about sum and difference formula. Now, how do we take this into the realm of products? Let's see. Um, so if you look at what we have up there, right, you will know that when we add equation one and equation two together, that is, we're adding these two. So when you add those two, what happens? That means you have sine A cos B plus sine A cos B. That will simply, so that means we have sine A plus B plus sine A minus B. And that is equal to sine A cos B plus sine A cos B. That's 2 sine A cos B. Whereas cos A sine B plus cos A sine B, that's 0. So that will just cancel out like that. So we have that sorted that way, that sine A plus B plus sine A minus B is the same thing as 2 sine A cos B. So 2 sine A cos B. So call that equation 5. Now we are going to have so many equations in this case. Now, when you do equation 1 minus 2, what happens? Equation 1 minus 2. That means you have sine A plus B minus sine A minus B. And that is equal to what? Sine A cos B minus sine A cos B. In this case, that cancels out now. And what happens? When you come here, you have cos A sine B minus cos A sine B. That means you have cos A sine B plus cos A sine B. That is 2 cos A sine B. And that is equation 6. So that we are done with the signs. Can we talk about the cos expressions? So what if you have equation 3 plus equation 4? That is this plus this. That means you have cos A plus B plus cos A minus B, cos A minus B. And that is equal to cos A cos B minus cos A cos, I mean plus cos A cos B. That's simply 2 cos A cos B. Call that equation 7. Call that equation 7. And then we have equation 3 minus equation 4. That means you have cos A plus B minus cos A minus B. That means you have cos A minus cos B, that's 0. Then minus sine A sine B minus plus sine A sine B. That's minus sine A sine B minus sine A sine B. That will be minus 2 sine A sine B. Minus 2 sine A sine B. And, to make things look better, you can actually transfer the minus to the other side such that you have, you have this coming this way. So you have cos A minus B, cos A minus B, right? Let me write that properly. Because when you transfer the minus here, right, it becomes minus cos A plus B plus cos A minus B. So that would be cos A. That's better written as cos A minus B minus cos A plus B. So the minus switches things over right there. And then this is now equal to 2 sine A sine B. And that is equation 8. That's equation 8. So now we have another set of equations that, don't forget where we started from. We started with sum and difference formula, and now we have gradually, you can see that this sum now has resulted to this product. This sum has resulted to this product. This sum has resulted to this product. This sum has resulted to this product, and so on and so forth. But then there are other things we may want to do with these things. So let's go for that. Now, the next set of things we want to do, now you see A plus B, A minus B, all over the place. Can we do this? Can we just say that? Can we have A plus B? Okay, let me do it this way. Let's say let A plus B be equal to C, and then A minus B is equal to D. Can we do that? So everywhere you see A plus B, that's C. Everywhere you see A minus B, that's D. So then you can call this equation 9. So call this equation 9, and then call this equation 10. So with that now, we can do this. We can actually have, we can say equation 9 plus equation 10. What does that give us? That's A plus A. That's, we are adding this and this. A plus A is 2A. Then B plus minus B, that's B minus B, that's 0. Then this is C plus D, since we are adding. So 2A equals C plus D. That means that A is actually C plus D divided by 2. If you like, it's the same as half into C plus D. And then you can call this equation 11. Like I told you, you're going to have so many equations there. But I mean, if you follow it logically, you'll understand the whole thing. So now let's go for equation 9 minus 10. So we've just been adding and subtracting all the way. So equation 9 minus 10 will be A minus A, that is 0. Then B minus minus B, that's B plus B, that's 2B. And 2B equals C minus D. That means that B itself is C minus D divided by 2, which can be also written as half into C minus D. And that is equal to equation 12. All right? That's equation 12. So now that we have taken, we have A to be C, half C plus D. We have A plus B is C, A minus B is D. So we can go back to equations 5 to 8. Equation 5, 6, 7, and 8. Everywhere we have A plus B, A minus B, we change them to C and D. Whereas anywhere we have A and B, we change A to half C plus D, and we change B to half C minus D. So that will bring us this set of expressions we actually need to work with, and then we take some examples. So let's go for that. So from 5, right? From 5, 5 is sine A plus B plus sine A minus B. So we can say now that from 5, okay, yeah, we can just say 5 becomes, 5 is sine A plus B plus sine A minus B equals 2 sine A cos B, right? So, so that means we have sine A plus B is now C plus sine A minus B is now D, and that is equal to 2 sine A cos B. That is 2 sine A. Don't forget, A now is half C plus D. Sine half C plus D cos B. That's cos half C minus D. Call this equation 13. Okay. And then the next one we have, of course, 6. 6 is sine A plus B minus sine A minus B. So 6 becomes sine C minus sine D equals, that is 2 cos A sine B. 2 cos half C plus D sine half C minus D. And that is equation 14. Now what does 7 become? 7 becomes, 7 is cos A plus B plus cos A minus B. That is cos C plus cos D. And that is 2 cos A cos B, right? That's 2 cos A cos B this. So we have 2 cos half C plus D. Then another cos. 2 cos half C plus D cos half C minus D. That is equation 15. And then lastly, 8 becomes cos C minus cos D. And that is 2. Oh, yeah, because that should be 2 sine A sine B. So in fact, it's cos A minus B minus cos A plus B. So we have to turn it over. So cos A minus B, cos A minus B minus cos A plus B. So cos A minus B should be cos D minus cos A plus B should be cos C. That's important. And then that results to 2 sine A sine B. So that's 2 sine half C plus D sine half C minus D. And that is equation 16. Okay, so it's been a very long journey to get here. So all this now can be referred to as the sum and product formula. And that what that means is that sine C plus sine D gives you 2 sine half C plus D multiplied by cos half C minus D. So sum, here you have a sum, and on the other side you have a product. That's the idea of sum and product. So sine C minus sine D, that is 2 cos half C plus D multiplied by sine half C minus D. So sum here, product on the other side. So cos C plus cos D, that's also a sum. Then you have 2 cos half C plus D cos half C minus D. Now, minus is it's technically a sum, right? Difference is technically a sum, except that it is in the reverse. So we consider it basically as a sum. So cos D minus cos C now, this is another expression, right? Like I said, this is another expression in the sum and product formula. And then this is the last expression here. Now, the question is, what do we do with this? Now, there are some circumstances where it is difficult. Maybe you have a product of trig ratios and you cannot do anything with that, especially if you have to integrate. It is easier. For instance, it will be easier to integrate a sum than to integrate a product, right? Like, interestingly, I've done some work on integration. Maybe I can do some examples of this in under fast math solutions. You may want to watch out for this. So if you are told to integrate a product, it may be difficult to integrate that product compared to the sum. So you can use this technique to convert a product to a sum for easy integration, right? Okay, so let's take some examples. I have a couple of examples here for us to try our hands on. So I have 5 of them. So I'll do the odd number examples and I'll leave the even number examples for you to try. So those will be your practice questions under this. So let's go. All right, let's take the first one. The first one, now talking about examples. Examples. So the first one is this. We want to express sine 5x plus sine x, sine 5x plus sine x as a product, as a product, as a product of trigonometric ratios, as a product of trigonometric ratios. So how do we do that? So express that as a product of trigonometric ratios. So you can see already this is sine something plus sine something. So you have to come back to your expressions that where do you have sine something plus sine something? That's like sine C plus sine D. I know sine C plus sine D is 2 sine half C plus D cos half C minus D. Okay? So since it is sine something plus sine something, so you can take care of that. So we have, say, from sine C plus sine D is equal to, what's that now? 2 sine, right? 2 sine half C plus D. So that is 2 sine half C plus D cos half C minus D. That is the expression that really works for that. So it's comparable. So in this case, now you can see that if you compare the two, this is similar to sine 5x plus sine x. This expression is similar to this. So, and from here, you can see that C is equal to 5x and D is equal to, x, right? D is 5x. I mean, C is 5x and D equals x. So it means that from here now we need to find, we need C plus D and we need C minus D. How do we do that? So call this A if you like and call this B, and we need the sum and the difference. So say A plus B, that is the same thing as C plus D, and that is equal to 5x. I mean, 5x plus x. I mean, there's no point wasting time with that. So 5x plus x, that is simply 6x. And then do A minus B, which you also need. That is C minus D, and that is 5x minus x, which is simply 4x. Okay? So now that you have C plus D and C minus D, you can now go back to this part. Now you have sine 5x plus sine x, and that is equal to 2 sine half C plus D. C plus D is 6x cos half C minus D, which is 4x. Looking at this now. So this is C plus D. This is C minus D, like that. So that means we have 2 sine half of 6x is 3x, half of 4x is 2x. So we have 2 sine 3x cos 2x. So that means that sine 5x, sine 5x plus sine x is equal to 2 sine 3x cos 2x. So with that, we have expressed that sum as a product. That is what we're expected to do with that. Okay, so let's take another one. Let me look at an appropriate one so I don't repeat the same thing. All right. Okay, trying to look for an appropriate one. Okay, let's take 2. Let's take 2. The second example, example 2. So the question here is to express, express, express. Okay, now what we just did, let's just reverse it. That's simply what we have to do. So express 2 sine 3x cos 2x as a sum, of trigonometric ratios. So that is us reversing what we just did as a sum of trigonometric ratios. Okay. So again, we have 2 sine 3x cos 2x. So on the product side, what does this look like? If you go to all the 4 expressions we have, where do we have? We have sine and cos, right? We have sine and cos. Sine something, cos something. So again, that we have sine something here and we have cos something here. And that relates to that expression as we have it. Okay? So it means that if you look at that now, this is similar to where we have sine half C plus D cos half C minus D, which is the same thing as sine C plus sine D. So now we can establish some commonalities. For instance, this 2 is this 2. Then this 3x now is in front of sine. So this 3x is the same thing as half C plus D. So we can write that out. We know that's 3x, or better still, half C plus D is equal to 3x. That implies that if we multiply through by 2, it means that C plus D is equal to 6x. That is 2 times 3. That is 6x. So we can call this equation, let's call this equation P, if you like, or something else. So on the other hand, right, we have cos 2x. That's like half C minus D because this is 2 sine something, cos something. So it means we can also say that half C minus D is the same thing as 2x. And if you multiply through by half again, you have c minus d equals 4x. And that is equation Q, like that. So now, we just need c and d now. And by solving this, we can get c and d. By looking at p and q, we can solve for c and d. So we can just fix all of that up. Okay, so if we have p plus q, so if we add up p plus q, right, that means this is equation P, this is equation Q, right? If it's half P plus Q, that means C plus C is 2C, then D plus minus D, that's D minus D, which is 0. Then 6x plus 4x is 10x. That means that C is 10x divided by 2, which is simply 5x. So anywhere you see, so it means C is simply 5x settled. Then on the other hand, we can have P minus Q. P minus Q, like that. So P minus Q would be C minus C, 0. D minus minus D, that is 2D. Then 6x minus 4x is 2x. Again, divide through by 2. You have D is 2x all over 2. And then D is equal to x. Okay? So D is x. So now you've got what you need. So you can finalize by saying, therefore, from here, right? From here. Therefore, now you have your C and D. C is 5x and D is x. So you can say, therefore, 2 sine half C plus D. Okay, do we even have to do this? We have 2 sine. So we can say, therefore, 2 sine, what exactly we have? 2 sine 3x cos 2x. 2 sine 3x cos 2x is the same thing as sine C, where C here is 5x plus sine D, and D here is x. So that is how to reverse what we did initially. Then I'll take a third example and I'll give you 2 practice questions for this. And that'll be all for sum and product formula. Okay. So let's take this. Okay, let's deal with this. Let me call that, let that be our example 3. Example 3. And what does it say? Example 3 says, if sine theta, if if sine theta plus sine phi, sine theta plus sine phi is equal to A, and cos theta plus cos phi is equal to B. The question is, we are required to show that cos squared half into theta minus phi is equal to 1 over 4 into A squared plus B squared, like that. So that's what we have. Okay, so now from all of these things that we have, what exactly can we do? So first thing, you can see here already. So from what you have, we can pinpoint what we have, right? Sine theta plus sine phi is A, and we have cos theta plus cos phi is B. All right. So let's start. So considering, 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 considering sine theta plus sine phi equals A now. This is sine something plus sine something, like we've always said. Of course, this is similar to where you have sine C plus sine D, which is equal to 2 sine half C plus D cos half C minus D. So that's the kind of thing we just did now. So sine plus sine. So that would just be 2 sine, 2 sine half theta plus phi, then cos half into theta minus phi, and that is now A. So this expression now is exactly this on the product side. So sine C plus sine D is 2 sine half C plus D cos half C minus D. That is exactly what we've done there. So this is exactly this expression. So we can take note of this because it is going to be useful. later, because now the reason why we're doing this actually is because at the end of the day we have theta minus phi, whereas in what we have initially there was no theta minus phi. So that means that we are going to have changed some things to the product form. Okay, so we have taken care of that. Can we also consider cos theta plus cos phi equals b? Cos theta plus cos phi equals b. When we have cos plus cos, what happens? Cos theta plus cos phi. So, okay, here you see cos c plus cos d is cos cos. 2 cos half c plus d cos half c minus d. So, it means that this expression is going to be similar to 2 cos half theta plus phi cos half theta minus phi, and that is equal to b. So we have that again. Okay, so we have actually got the product forms of the two sums we have. So the next thing we may want to think about is this. At the end of the day, we want to show that cos squared half into theta minus phi equals 1 over 4 a squared plus b squared. So, of course, invariably, that means that we are going to have to square these two expressions we have. In fact, let me name these expressions. Let's name this star, let's name this star and name this star star, star star. Okay? So, of course, we see that we have to square, right? Because at the end of the day, we see a square on top of cos here. So can we do squaring, let me write that properly. Squaring star. If you square star, that means you're squaring this expression now. So if you square this, see what you get. That means you're squaring the whole of this expression. That means you're going to have 2 raised to power 2, that's 4. Then if you square this, that's sine squared half theta plus half cos squared half theta minus half, and that is equal to a squared, right? So we have 4 sine squared half theta plus phi, then cos squared half theta minus phi, and that is equal to a squared. So you can call this, what should we call this now? Let's call this, that's why numbering is good. I'm going to do 3 star now. Let me do 3 star. That's a lot, but let's just do that. Okay. So let's call that 3 star. And then if you square 2 star, squaring double star, that is, we want to square this expression now. So that means we have again 4 cos squared half theta plus phi cos squared half theta minus phi, and all of that is equal to b squared, and we can call that 1, 2, 3, and 4. That's 4 star. Okay. Now, from the expression you see here, you see that at the end of the day, it's like we have cos squared half into theta minus phi. That's taken care of. And then we have a squared plus b squared. So it means that at the end of the day, we have to sum up these two things you have got now. That's the only way a squared and b squared can come together. So intuitively, right, it means we have to add these two expressions together. And that's what we're going to do. So we can now say um, adding 3 star, 3 star, and 4 star. I mean, it's easy if you number those things. So you just call the numbers instead of these stars I'm drawing. But it's okay. So if you add those two together, right? See what you get. So okay. So you have 4 sine squared half into theta plus phi cos squared half into theta minus phi. All right. Then plus again plus 4 cos squared half into theta plus phi cos squared half into theta minus phi. That's on the right hand side. On the left hand side, all of this will be equal to a squared plus b squared. I mean, that's on the left, right? On the right, you have a squared plus b squared. And that's exactly what happens here. So what can we do with this expression on the left? So obviously, it looks like we can tidy things up. So for instance, you see cos squared theta minus phi is common. So cos squared theta minus phi is common to both. So we can have cos squared half. I mean, cos squared half into theta minus phi is common. So cos squared theta minus cos squared half into theta minus phi into 4. In fact, 4 is common too. So let's take the 4 out. Yeah, we can take the 4 out. 4 is common. We have 4 here and there's 4 here too. So what do we have left? We have sine squared half into theta plus phi. All right. Plus cos squared half into theta plus phi again. And that is equal to a squared plus b squared. Interestingly, this is looking sweet. Sine squared something plus cos squared that thing is 1, right? So it means everything in brackets actually goes to 1, so that's so good. So from here now we have 4 cos squared half into theta minus phi, theta minus phi, uh, theta minus phi. So everything here is actually 1 now because sine squared half into half theta plus phi plus cos squared half theta plus phi is 1. And all of this is equal to a squared plus b squared. Okay. So, so we have 4 cos squared half into theta minus phi equals a squared plus b squared. So finally, if you divide through by 4, you have cos squared half into theta minus phi equals 1 over 4 into a squared plus b squared. And this is what we expected to prove. We're told to show that if we are given those things, that cos squared half into theta minus phi is equal to 1 over 4 into a squared plus b squared. That's what we had in the original question. So this is what we're expected to show. And now we have shown it. Okay. So that's done. So let's take 2 practice questions and this will be done. Practice questions. Practice questions. Okay. So try your hands on this to be sure you really get the idea. Let's start with okay, I think I've done 3 out of the 5 examples. So you have 2 to tackle. Let me see. Okay, yeah. The first practice question here would be this. Show that sine 2a, sine 2a cos, okay, let me take that down so we can have enough space. Show that sine 2a cos 4a, sine 2a cos 4a plus sine 3a cos 9a is equal to half into sine 12a, sine 12a minus sine 2a. I don't like that. Let me make it easier. So show that sine 2a cos 4a plus sine 3a cos 9a is equal to 1 over 2 into sine 12a, sine 12a minus sine 2a, like this. So this is what you're expected to show. First question. Second question, of course, is I see a bunch of products here. You want to find a way of resolving that to get half into sine 12a, sine 2a. Well, a hint, a very easy hint here is to multiply through by 2. So you end up having 2 sine 2a cos 4a, 2 sine 3a cos 9a. Sine cos look like sine plus sine something plus sine something, and then you can take care of them in parts and then put them together later. That's I've given you, pretty much the solution for that. Okay. The next question is you want to that, show that show that sine 7x plus sine x minus 2 sine 2x cos 3x is the same thing as 4 cos squared 3x sine x. That's what you have to show for the second question. Show that sine 7x plus sine x minus 2 sine 2x cos 3x is the same thing as 4 cos squared 3x sine x. Well, what you have to do here is this is a sum, make it a product. Then if there are common things, they factorize, and then you can tidy things up. All right, so that with that, we come to the end of the sum and product formula, which helps you to turn the sum of trig ratios to the product of trig ratios, and it's necessary under certain circumstances. Like when you want to integrate a product of trig ratios, that may be difficult, so you may need to turn it into a sum for easy handling. All right, so thank you for being here all, up to this point. If you have not subscribed to this channel, please be sure to do that. Make sure you hit the notification bell so you can always get alerted each time I release a new video. Then be sure to comment, be sure to like, and share with others, because this will definitely be helpful to so many people. Thank you for coming around. See you in the next video.